Welcome to Day 3 of Advancing Sciences. I'm Melissa Coburn. I'm the Director of Enterprise Systems in the Global Technology Services section of Protolabs, and Protolabs is headquartered in Maple Plain, Minnesota.
I'm Dawn Hartung, and I am the Director of Sales and Marketing at Activated Research Company. We're an analytical instrument company in Minnesota, and we are your hosts today.
We're so excited to be here with you today because both Dawn and I want to inspire you. We are both passionate about science, technology, engineering, arts, and math, the STEAM subjects, and we want to share that passion by giving back to our community through our involvement in advancing sciences. Before we get into the incredible session ABBOTT has planned for us today, we want to talk with you about the importance of CPR. In a few minutes, we'll be joined by Sarah Sanchez, the Community Impact Director at the American Heart Association.
Did you know the AHA is a worldwide leader in first aid, CPR, and AED training, educating more than 22 million people globally in CPR each year? You might hesitate to give CPR, but you shouldn't. You could save someone's life.
Of all the moments you share with your best friend, the greatest could be the moment you save her life. Every second counts in cardiac arrest. Learn hands-only CPR and be the difference for someone you love.
Thank you, Melissa and Dawn. My name is Sarah Sanchez, and I'm a Community Impact Director at the American Heart Association. The American Heart Association envisions a world where no one dies of cardiac arrest. Who can tell me what cardiac arrest is? Type your answer in the chat box. So we have A, sudden unexpected loss of heart function, breathing, and consciousness. B, a blockage of blood flow to the heart muscle. C, a condition in which the force of the blood against the artery wall is too high. Or D, all of the above. All right, answers are coming in. So if you said A, you would be correct, a sudden unexpected loss of heart function. To those of you who answered B, that is actually the definition of a heart attack. So to help you remember the difference, think of a cardiac arrest as an electrical problem since it deals with the heart rhythm, and a heart attack as a plumbing problem dealing with blood flow. The two are different, but research and understanding of each is very important to the AHA. So CPR, if performed immediately, can double or triple a person's chance of surviving cardiac arrest. And sadly, CPR only happens about 10% of the time when a cardiac arrest happens outside of a hospital. You can make a difference in your school and community by learning the two simple steps for CPR. The first step, call 911. Second step, press hard and fast.
If you see a teen or adult suddenly collapse, it's important to act fast. Helping to save a life is easier than you might think. Just start hands-only CPR. The first step is to send someone to call 911 or call 911 yourself. Then get directly over the victim. Put the heel of one hand in the center of the chest, then put your other hand on top of the first. Then push hard and fast in the center of the chest until help arrives. It's important to push, giving 100 to 120 compressions per minute, which is about the same tempo as the song Stayin' Alive. Let's hope you never have to use hands-only CPR. But if you see a teen or adult suddenly collapse, don't be afraid to try it. Remember, call 911, then push hard and fast in the center of the chest until help arrives. Your actions can help save a life.
So hands-only CPR is easy to learn, and if you're a music lover, the tempo is easy to remember. As you saw, the Bee Gees song Stayin' Alive tends to be the go-to when administering CPR. However, if you're not familiar with that song, Uptown Funk by Mark Ronson and Bruno Mars is also an excellent option. These songs will help keep the recommended tempo if you ever do have to give CPR. If you have any questions, please type them in the chat. Otherwise, I'll turn it back to Dawn and Melissa.
Thank you, Sarah. Okay, it looks like we don't have any questions at this time. Now we'll move into our featured session with ABBOTT to learn about the variety of roles engineers take on in the workplace. Tess from ABBOTT will take us away.
Hi, everyone. All right. My name is Seth Gilbert. I'm a biomedical engineer, and I work for ABBOTT. ABBOTT's fundamental goal is to help people live fuller, healthier lives, maximizing their potential at all ages and stages of life. I, like many of you, loved math and science in school. I decided to go into engineering in college because I knew it would be a fulfilling and challenging pathway, and I knew it would lead to a career where I could help improve lives. Today, I'll talk to you a little bit about ABBOTT and why we believe a STEM education is so critically important. I'll also let you hear from other engineers that I'm fortunate enough to work with in roles that range from research to marketing. If you have any questions or thoughts, I encourage you to add it to the chat as we go through the program, and I'll try to keep an eye on the chat window and answer questions when we get to the end. You can go to the next slide. All right. ABBOTT is a global healthcare leader that helps people live more fully at all stages of life. I encourage you to use the chat. Do any of you have any family members that work for ABBOTT or know of anyone that works for ABBOTT? We are more than 100,000 people around the world. We've been in business for more than 130 years. We serve people in more than 160 countries with a portfolio of life-changing technologies that spans the spectrum of healthcare. We have leading businesses and products in medical devices, diagnostics, nutrition, and medicine. Let me walk you through just some of those ABBOTT businesses. Go to the next slide. All right, our medical devices use advanced technology to keep hearts and arteries healthy with the products including pacemakers, heart valves, and cardiac mapping systems. This is actually the area I work in, and it's an area that's obviously so important to the AHA. My colleagues will speak to you today about the work we do within this space. We also treat chronic pain and movement disorders with neurostimulators that target specific areas of the brain. And we give people with diabetes better insights, more freedom and less pain by tracking glucose levels without finger sticks. Our nutrition business builds and maintains your health from infancy onward. These products include things like Similac Instant Formula and Pedialyte and Ensure. Our diagnostics division provides information to guide effective treatment decisions. This is especially important in 2020 with all that's going on in the world. Some of you may have heard that ABBOTT's tests for the coronavirus. We've launched a series of 7 tests in the US to date to help fight COVID-19 pandemic, from physicians' offices to urgent cares to hospitals and to hotspots where help is needed the most. This is one of the many reasons I'm proud to work at ABBOTT. It's exciting to know that research and science can help us tackle the world's biggest and most impactful problems. Next slide. All right, this year looks a little different in a virtual world, but we wanted to remind those of you who have attended in the past what we shared and learned in our past years. If you've joined one of our events in the past, let us know again in the chat window. In our electrophysiology business, that's one of the areas that keeps our heart and arteries healthy. We offer devices that let doctors analyze and treat abnormal heart rhythms. These include our cardiac mapping system, which allows doctors to diagnose a wide range of arrhythmias. The system features a 3D image of the heart and its activity in real time, helping a doctor find specific tissue that's causing the heart to beat irregularly. We had you last year steer a catheter inside a heart model and show you exactly how the doctor would map the inside of a heart during treatment. They'd be looking for voltages and timing of activation from within the heart to determine where an arrhythmia started and how to treat it. For anyone who was there last year, did you hit all the heart targets? Anyone? All right. All right, if you want to go to the next slide. ABBOTT is a global healthcare technology company that recruits world-class scientists and engineers. Today's students are the innovators and inventors of tomorrow. That's why it's vital for us to inspire and train young people to pursue careers in STEM. So just a few facts for you guys here. 92% of boys and 97% of girls lose interest in STEM if not engaged by the 5th grade. And maybe more impactful for those of you who are in high school, only 6% of high school seniors will get a bachelor's degree in a STEM field. Are any of you planning a STEM degree? Hopefully. All right. And out of 65 countries, Americans score 17th in science and 25th in math ability. The U.S. is a world leader in so many things, but we have a lot of work to do, and that's why it's important for education in STEM to continue to grow here in the United States as well. The STEM job market grew 45% in 2018. 15 of the fastest growing occupations require significant math and science participation. This is important to consider when you're looking at investing in a degree or an advanced degree. Understanding how quickly the job market can change, I encourage all of you to look beyond what is there today. What will the jobs of the future be? Currently, only 16% of the U.S. bachelor's degree will specialize in STEM. Again, we hope to improve this, and people in STEM fields can expect to earn 26% more money on average and be less likely to experience job loss. Again, your degree is an investment. Money certainly shouldn't be the only thing to consider, but we need to also invest in something that we are passionate about. But we want a return on our investment as well. I feel fortunate to have found something that I'm both passionate about and allows me to provide for my family. That may be ways off for you now, but it's important to think about what priorities and goals you have for the future. I landed in the medical device industry out of college and have stayed here ever since. I worked in a number of roles, research and development, clinical, quality, and now I lead a new project development team within the cardiac electrophysiology space. We want to highlight today the variety of careers just within our industry that can come with a STEM education. We're going to hear from 7 of my engineering colleagues who have chosen different pathways and ask you a few trivia questions along the way. Let's go to the next slide. These range from manufacturing and operations, research and development, marketing, sales, legal and intellectual property, medical and clinical affairs, quality assurance, and program management. Go to the next slide. We'll start off with Noelia. Noelia is a manufacturing engineer. Her work helps make our manufacturing lines and facilities run smoothly and reproducibly to make safe and effective products each and every day.
My name is Noelia Loisiga, and I'm a manufacturing engineer at ABBOTT. As a manufacturing engineer, day to day, I'm in charge of making sure production is functioning. What excites me every day is that I don't know what to expect that day. I think that's what I find most exciting about my job. It's always something new and it just never gets boring for me. Being organized helps accomplish my job, mostly when I'm tearing apart a piece of machinery. I need to remember how to put it back together. Yeah, it's okay to fail sometimes. You don't have to be a perfectionist or perfect to be in engineering. You just have to be willing to try and work hard.
All right, now we're going to do some Q&A to see who's been listening. So please use the chat function to cast your vote as I read through the questions. The first one here, what % of high school seniors will get a bachelor's degree in a STEM field? All right, go ahead. Let's see those responses. All right, A, B. All right, A is correct. I'm going to just click. Yeah, just 6%. So you guys can help us improve that. All right. Next, we'll talk to Hannah in research and development. Research and development helps us design medical devices and turn concepts or needs of our doctors and patients into actual products.
My name is Hannah, and I'm an R&D engineer in ABBOTT's electrophysiology division. So I enjoy R&D. It's the development of new technology. It's kind of being on the forefront of new science. It's a very interesting work. It's, I think that it's the best. Engineers make a difference in the world because engineers are just inventors, and they've been the people that have invented everything from cell phones to pacemakers to the airplanes that fly in the sky. And they've undoubtedly created new technology that has made the world a better place. A couple things about me that I enjoy doing when I'm not at work is I enjoy playing soccer. I've done that my whole life, and I continue to play for fun. I love to bike, and so that's something I do quite often. And I just like to hang out with friends and enjoy myself.
All right, next question. What is cardiac electrophysiology? A, the study of heart's mechanical function used to help guide placement of artificial heart valves. B, the study of heart's electrical system used to diagnose abnormal heartbeats or arrhythmias. C, the study of pacemakers and defibrillators. See your responses. Nice. I think solid Bs across the board. Yes, this is the study, and I think we talked about this earlier, right? There's plumbing and there's electrical, and the electrophysiology is the electrical system within the heart. Awesome work. All right, next up is Christy, who works in marketing. Marketing is one of those areas that you may not traditionally think of STEM being important, but in our area, it's critical that our products meet the needs of our customers, which means we need a marketing team that can engage in some of the most technical conversations and translate what someone in research is doing into a critical customer need.
My name is Christy Tanaway. I am a Global Product Marketing Manager for the EP, or Electrophysiology Platforms team. If you're interested in becoming an engineer, the best thing you can do right now is to really dive into math and science. Be interested, be curious, and just want to learn. In engineering, we need people of all walks of life, because if everyone was exactly the same, they would likely think the same way. And so in order to be creative and solve those problems, we really need people that think differently and can bring those different ideas to the table. So one interesting fact that my job has actually led me to is traveling much of the globe. I had the opportunity to travel to both China and to Thailand within the same trip. I was able to hike along the Great Wall, as well as spend a day with the elephants in Thailand.
All right, our third question. Why would a STEM background help in a marketing career for electrophysiology? A, our customers are STEM students, many who went into science and even engineering before getting a medical degree. B, we make complex medical devices that require technical discussions across all functional areas. Or C, our education and marketing materials need to reflect the latest science and appropriate uses of our devices. Or D, might be a An easy one, it looks like. That's great. All right, see lots of D's. That is correct. All right, next up, we will hear from Katie, who is on our legal team. We need to protect the ideas and inventions that come from ABBOTT, and Katie helps us do that.
My name is Katie Rollin, and I'm an intellectual property counsel at ABBOTT. So what I really do is I work with a lot of scientists and engineers. When they come up with a great new idea, I help let the federal government know that they've got this idea and file what's called a patent in order to kind of define that idea and make sure that everybody out there knows that this was ABBOTT's idea. It's really important to have diversity of background in the STEM field. I think it comes from the ground up, from the problem you're trying to solve, from coming up with what that problem is, all the way to the solution. People come from all sorts of backgrounds and they approach problems in very different ways. And something that I might see as a problem, someone else might not, and vice versa. The projects and products that I work on really do make a difference to the quality of people's lives. And that's something that makes me really proud to work here.
All right, question number 4. What is a patent? A limited duration property right relating to an invention that is new, useful, and non-obvious. B, includes an invention of abstract ideas, theories, and scientific principles. Or C, both A and B. All right, good. I see a little bit, some of A's and some of C's. The answer is A. Patents help us defend our work, but the patents need to be specific to a tangible product, not just an abstract concept. So nice work. All right. Next up is Alini. She works on our clinical insights team. We need clinical data to prove that our products and therapies are safe and effective. This means understanding the data coming from hospitals and research centers and helping guide us develop meaningful and useful clinical data for our customers. We have technical leaders throughout clinical roles, including Alini, on our clinical insights team.
My name is Alini Favilla, and I am a part of the Clinical Insights and Market Development team at ABBOTT. As an engineer, there's a lot of very difficult problems that you may face and are being asked to come up with a solution for that problem. And at times, I felt just giving up. This problem is really hard. And so this aha moment was hey, if we all work together and we bring our different expertises to the table, we will be able to come up with a solution and, solve this problem that at one point in time almost seemed to be something that was just going to completely derail our entire project. My advice would be to just be curious about the world and be inquisitive, to want to learn and understand how things work and why things can function the way they do.
Okay, question 5. Which countries or regions have the most undergrad majors in engineering? A, the US, B, China, C, Europe, D, Singapore. Anyone have responses? Oh, there we go. A few. All right. The answer is B, China. 6% of the U.S. undergrad majors are in engineering compared to 12% in Europe, 20% in Singapore, and 40% in China. You may remember the U.S. wasn't the leader in scoring for math and science. That was a fact I shared before, and we need to continue to encourage our youth to pursue these important degrees and eventual careers. All right, next up, Tiffany. Tiffany works in our design assurance team and helps make sure that our products are designed and tested in a way that keeps everyone safe before they come to market.
My name is Tiffy Yan, and I'm a Senior Design Assurance Engineer in the Electrophysiology Division. A day in the life of a design assurance engineer is unlike others. Some days we're in the lab working with R&D, testing new devices and making sure that our devices meet product requirements. Last year we designed and developed a new catheter and it launched this year. And it was great to see feedback from physicians in the field saying that it's working and it's safe and it's really helping the patients. Engineers are needed in the world to build and create and make new things. From the bridge that you drive over to get to work, the phone that you use to surf the internet, into the medical devices that are saving patients' lives. Engineers make the world run. Without them, I don't know where we would be.
All right, what is the most commonly studied engineering discipline? A, biomedical, B, mechanical, C, civil, or D, electrical? All right, we've got a few in here. The answer is B, mechanical engineering, followed closely by civil and electrical. You hear a lot about, at least in this industry, biomedical engineering, but it doesn't top the list of degrees overall. We need a ton of mechanical and electrical engineers to design our products as well, so all are important. Finally, we'll hear from Nithya. Nithya is on our program management team. She helps lead new product development teams. This means planning out a development pathway for how much time and resources and money it will take us to develop a product. It also means working with each and every one of the functions we've already learned about. It truly takes all of these roles and jobs to ensure we can bring the best products to our patients.
Hi, my name is Nithya Mathad. I'm a program manager here at ABBOTT. The favorite part of my job is making a difference in someone's life, extending a person's life and bringing better quality in their day-to-day work. One of the surprising things about the engineering world is we have strong women engineers and leaders who are very successful today. We need to have a lot more girls come into engineering and build upon that so that it's no longer a surprise going forward. The most proud moment I've had as an engineer is working on a device my first daughter, who's 8 years old today, was born as a preemie. And when she was in the NICU unit, she was hooked up to one of the devices that I was an engineer on and developed. And very proud moment that my own child could work on a product that I worked on. So I think that's my most proud engineering moment.
All right, final question. What STEM career most interests you? This should be an easy one. Let's see, anyone have an opinion or which one sounds the most exciting? Awesome. Well, that's great. I hope that one of these areas and one of these speakers inspired you today. A STEM career can truly take you anywhere. Manufacturing, research, marketing, even sales, legal, clinical, quality, and program management. So I encourage you to look beyond just one type of degree or career. We need scientists and engineers just like you to keep making progress and pushing us forward. Go to the next slide. Yeah, so again, we heard from all of these different career pathways today, and we encourage you to continue to look and pursue different areas within med device or elsewhere. I think that's all. I'll open it up for questions. I think I did see some on the chat as we went, but if you have a new question, feel free to add that to the chat window. I'll try to scroll up here and see if there's some that I can help answer as we went. right, one was I've worked in a few areas. What was my favorite and why? I'm currently in program management, and I really enjoy that. I think starting off as an engineer, research and development was a really good place to start. It's such an interesting and fast-moving area that I, really encourage people to look into. But I also currently love program management and love getting to look at that cross-functional team and work with all these different people that I've been fortunate enough to work alongside. So both are great. Let's see, what else? What kind of degree do you need to be an engineer? I think we talked a little bit about that. In our area, right, the most common ones I hear on a day-in, day-out basis, biomedical, electrical, mechanical, those are really key engineering degrees for the med device industry. And then I see one more question here. What kind of degree can you get an engineering job to go into pre-med? So I was biomedical, and this was a while ago now, but I do remember that specific biomedical degree where I went, which was University of Wisconsin-Madison. We always said about a third of the people go into industry, a third of the people go into a graduate program, and a third go to pre-med or med school. So biomedical would be great, especially in electrophysiology, since it is the electrical system within the heart. If you are interested in the cardiac space specifically, electrical engineering is actually a great degree as well. Just seeing if there's any others come up here. Most memorable experience as an engineer. I think I've worked with a lot of physicians and doctors. We've been fortunate enough to bring them in and ask for their advice and feedback on different medical devices. That's been really memorable, working directly with those physicians. And then in one case, I've been fortunate enough to go out to the field several times and see our products used in patients. In one of those connections I made with the physician, he actually let me come into the pre-op room and talk with the patient and their family before they went into the procedure. So getting to really hear firsthand from a patient, their anxieties about the procedure and things like that going in was very insightful and interesting. It helps you kind of put yourself in the perspective of the patient, and as you're designing these products, know kind of what they're wondering as they're going into a procedure. That was pretty memorable. All right, a few more here. What would people be surprised to learn about your role or about engineering? Let's see. So I work in program management now, and I think it maybe isn't that informative in what it does, but it's a new product development management. So I get to work with all of those different functions. So marketing, regulatory, quality, clinical, across the board, finance, everybody. And I think that it's a really cool position for that reason. You get to see all these different perspectives and kind of bring them all together to come up with a product that's going to be useful and safe and effective. And I think the last one I see here, what advice would you give to high school students looking to major in a STEM career when they go to college? I think the biggest thing that I didn't realize going into college was how much your career or how much your degree is an investment in your future. And not just looking at what am I interested in. Well, that's really important. It's also what jobs are there at the end of that. And I think just really doing your homework on what types of careers you want and what pathways can get you there. I think that was really interesting and really good to look at it like an investment in your time and in your money as you move into, your future career. And then I see one here just came in. Do you have a mentor? What's the biggest takeaway you had from them, and how could I find one? That's a good question. And I remember this being I had a similar question when I was in high school and in college. I have been fortunate enough to have mentors throughout my career, so really lucky to work with a bunch of people who helped guide me as I've made progress through my career. So I do have several mentors. I would say the biggest takeaway is they often just come very naturally, that it's not like you have to go out and seek them. The best mentorships that I've had have been through just engagement with someone. It's usually someone at a slightly higher level than where I'm at. So maybe one of our VPs or a director or somebody early in my career that you engage with in a career setting or in a professional setting, and then kind of help form a relationship over time as you get to know them. And I think seeking their honest opinion of your work and of where you might have blind spots in how you're managing your work or managing working with people, I think that's been the most effective. So they've been kind of these natural relationships that form out of a work environment, and kind of being able to tap into that to get some really honest feedback that helps you look critically at your performance and kind of where you want to go and how you want to be perceived within your career. All right, and then I see one more. Would a mechanical engineer degree work as well as pre-med route, trying to keep options open for engineering medical field? Yeah, I think so. I mean, the important thing, and actually in college was worked in our dean's office in the electrical engineering college, just to help guide students as they made their kind of degree pathway. I think pre-med is something that can be, there's so many undergrad degrees that can get you into the medical field. The great thing about engineering is that if you decide after 4 years you don't want to go to medical school, you still end up with a really solid degree that can get you a great career without that medical degree. So it is, I think, across the board, engineering is a great pathway. I think the most important thing as you enter college is just to understand what those pre-med requirements are, and making sure the degree you're picking is open enough that you can add some of the areas in that you might need for pre-med that won't be offered traditionally in your route. So like mechanical engineering, for example, maybe you have some elective credits where you could take anatomy, physiology, some of those more pre-med pathway classes. I think it's important that you just look at how you get those into your class schedule as well. So kind of being open to the fact that you might need to use some of those classes or take some extra credits to kind of fill in the breadth of what you would need for a pre-med or a med school application. Let's see. Okay, good. There's good questions coming in. Did I do any internships? I did. I was super fortunate. I did internships with Kimberly-Clark. I did an internship with ABBOTT, actually, and with St. Jude Medical. And St. Jude Medical is actually how I came to ABBOTT officially. When we were acquired by ABBOTT, I came through St. Jude Medical. So highly recommend internships or co-ops. They're great opportunities. The ABBOTT one in general was awesome as well. They do a great job of placing you in all sorts of different areas, and they have even early career opportunities to kind of live in different areas and go through a series of different jobs before you decide that you kind of want to lock in on one. So we have different rotational programs that are super interesting. I think that's the best way to test out where you want to be. Like I said, I've tried a lot of different areas, R&D, all of those areas, and one of the best pre-screens for me was really the internship route. You can kind of go do an internship in quality, and then next summer go do an internship in manufacturing, and kind of even within college start to solidify what most interests me at the end of this. What careers do I really want to look into when I graduate? So highly recommend that. Let's see. Best schools for engineering. I mean, I'm really biased because I went to Wisconsin, so I mean, that's a great one. But I think, this is all what you want in a school, right? I think I had the perspective of wanting to go to a really big research college for engineering, making sure that you have those chances to, work in a lab maybe, or at least work with a professor who's doing research in an area. So that was really important to me. It's one of the reasons I chose a big school. But I think that there's plenty of opportunity all across the board. Minnesota, obviously, here is great as well. And then I think you've probably heard the big engineering schools, Michigan and others. So there's a lot of great things. The other thing to look into is what specific area of engineering are you interested in, because there may be a really great degree program at some school that's the best biomedical engineering degree or the best mechanical engineering degree, that type of thing. So If you know even more specifically what you want to do in engineering, you might want to start even narrowing in on specific pathway within it. Can a high school student do an internship at Abbott? I know the answer is yes, but I'll be honest, I don't know all the details. So I don't know if there's ways we can follow up, but I do know we have high school internships. So if we can get people information on that, we'll try to follow up on that. Yes, and Wisconsin has reciprocity with Minnesota for lower tuition, at least for now. That's great. So it's a good school, but so is Minnesota, to be fair. All right, that's all I see in the chat. Did I miss any? Okay, I don't see any others coming in, so I guess I'll leave it at that and turn it back over.
All right, thank you so much, Tess, for leading us through today's featured session. It was really great to hear not only from you, but all the different perspectives that you brought in. So I know you've answered a bunch of questions from our audience already, but we will spend the rest of our time today answering any additional questions that participants may have on today's content, or just in general, if you have questions about the program that Advancing Sciences is putting on this week. So I will, Dawn and I are available, as well as Tess is online here, if there are any additional questions. Let's see. So I see there is a question coming in about background for that Dawn and I have, and I'm happy to start that. My background, so another engineering school, I went to Iowa State as my engineering school. So that's another one that's not too far from here in the metro. As a high school student, I very much enjoyed math and science. And my physics teacher at the time said, well, you would be good in engineering. So that was my path to engineering. And when I was at Iowa State, industrial engineering was the one that stood out for me, and keeping things organized. I had 2 internships. I know that Tess brought up internships as an important thing. I had 2. I had one at a gas utility, of all things, and then I had another at Honeywell as a manufacturing engineer. And so I know when Tess was going through her interviews, manufacturing engineering was one that she showed. So after graduation, because I've been working now about 25 years in engineering and technology, I went to North Carolina and worked for a heavy-duty truck transmission company for a bit, and after that I moved out to California and worked for a bit in semiconductor, and then made my way back here to Minnesota, where I've been for a while. After being back in Minnesota and working in the thin film industry, I learned more about Six Sigma and Lean, and I got a mentor. And like Tess mentioned, mentors are so important. I had a mentor that helped me understand the importance of thinking about advancing your education and continuing to invest in yourself. And so I went back for a master's degree in management of technology. And that opened doors for me for additional roles where I learned more about quality and program management. And now I am with Proto Labs in Maple Plain, where I work in global technology services on enterprise and program systems. So like Tess mentioned, engineering can take you in so many different directions. I'll turn it over to Dawn.
Thank you, Melissa. So my background is a bachelor's degree in business management, so not the engineering field, but I can say throughout my career in sales and marketing, engineering would definitely be of help. And so a lot of the products that I had worked on, like Melissa mentioned about the semiconductor industry, that is part of my background. Worked at a company called Integris, and I was a product marketing manager at that organization. And having the engineering or the STEM background definitely would have been supportive through that. But just having that technical aptitude would have, yeah, again, been really, really helpful. But as a product marketing manager and having business management as a key with my education, it really helped to support my career to get into just the sales and marketing field. And stemming to where I am today at Activated Research Company, the customers who I'm working with and companies that I'm working with, the customers are mainly R&D scientists and chemists. And so the products are being sold into laboratories as well as to in process, so in manufacturing. So again, analytical instruments. And again, this is where engineering would really, really be helpful, even in a sales and marketing role. So many, many different ways to stem out of a career coming from an engineering background. So do we have any additional questions for today? If not, that concludes our program for the day. Please reach out to the AHA team at the email address at the top of the screen if you have any questions from this week. Otherwise, we will see you back here tomorrow at 10:30. Take care, everyone.